Back to Springfield in Jersey, and tonight's a parents' evening with a twist. Richard Dunn, maths consultant, is going to explain to parents how visualising calculations using paper cups is revolutionising children's understanding, and perhaps their own.
I'm going to help you by asking you to look at this rectangle just here. Can you see it? You say yes? Yes, right. Look, there's a bottom corner here, a bottom corner here, a top corner here, a top corner here. If I hold one juggling ball just here, that's at this bottom corner, isn't it? And that's the top opposite corner, isn't it? Now watch, I'm going to throw the ball to that top opposite corner. When it gets there, I'm going to say, now, and then I'm going to let it drop into my hand. Watch. Now, can you see the rectangle? Yeah. So, what's the top corner? Now. What's the top corner? Now. Now watch. Look at the rectangle. 3 balls. Now, 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 now. Can you see? You can see it differently now. That you can actually see this very thing that looked very complicated to begin with is now simplified because you're looking at this rectangle. And you can see that I'm better at it when I'm thinking about the rectangle and going, now, 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 now. That is the essence of all good teaching and learning. That some, oh, by the way, can you see the rectangle? Which is interesting because it's not there, is it? What it is just a thing which is not really there to support you into seeing it. It looks, when I do it now, it looks as if the balls are moving more slowly, doesn't it? But they can't be. It's only because I've framed your learning, I've given a structure to your learning. The best teaching and the best learning gives young people, gives your children a structure to their learning. So when I now start some maths, you're going to see that gradually you're going to see that I'm giving a structure to what your children are doing. So if I go up here and say to you, look, what we're going to do today is to use the cups. Now some of you have heard about the cups, haven't you? Point to the resources table. Try it. Yes, that's right, good. Hands down. Point to the resources table again. Good, hands down. Now watch. This table over here hasn't got any cups on. This is the maths table. All of you point to the maths table. Good, you're doing well. Now watch this. I can't pick that up, can I? That's not really cups, is it? That's only ink on the board. These are the real cups, but these are not real. So this is not real cups, this is only pretend. So when you see this, 2 add 1 add 2 equals 5, we call that a maths story. It's not real, it's just pretend. I need a helper.
You'll recognise the volunteer, Year 1 teacher, Linda Crawford.
I'm going to write the maths story. What do I use to write? This, isn't it? And you're going to act the real story. What does she use to act? The cups. I'm going to write the maths story, you act the real story. I write the maths story, you act the real story. I write the maths story, you act the real story. I write the maths story, you act the real story. I write the maths story, you act the real story. I write the maths story, and you're acting the real story. And when I write the maths story like this, she goes, she has to go 1, 2, 3, 4. How much on the maths table? 4 cups. And when she says 4 cups, she's telling me the answer to the real story, isn't she? But I write 4 because I'm writing the maths story.
The parents' reaction's been really positive.
The way she can understand it, talking in cups. When I was trying to do it, even with my fingers, she said, no, mummy, it has to be in cups. But she's doing it in cups. She can understand it perfectly, and I thought, well, that's the way we'll do it then, we'll do it in cups. All the cups out the cupboard.
I will write the maths story, you will act the real story.
Half cups are a great way of introducing fractions, Richard's next port of call with the parents. The teaching method has something for visual, oral and kinesthetic learners, even to the extent of moving absolutely nothing to emphasise naught.
What's in her hands? Nothing. She's good. She must walk over here. Put them down. Well done. I think of parents in the same way as a teacher working with a teaching assistant, that the important thing is a high degree of consistency, because the novice in any subject, and maths in particular, needs consistency for that initial learning in order for the relative untidiness of real maths to make sense to them. 2 times 4 equals 8. We are going to read what it means, but you will not race ahead of me because you'll get it wrong. Read it with me. 2 cups times 4 equals 8 cups. Let's do it again. Read what it means. 2 cups times 4. No, not cups. 2 cups times 4 equals 8 cups. They're cups, aren't they? They're cups. They're not cups.
Without using the term place value, the teaching method seamlessly introduces thousands and hundreds.
3,000 add to 1,000 equals, what's the number? 5. What's the word? Thousands. Hey, you're good at this. 300 add to 100 equals, what's the number? 5. What's the word? 100. I will speak the math story, you write the next math story. I speak 3. Done that all right? You spell it okay? Because this is how we spell 3 in maths. It's rather hard in English, isn't it? But in maths, it's ever so easy to spell 3. That's how you spell 3. In math, if I speak the word 1,000 just here, you just go, do it. Because that's how you spell 1,000. What's that say? 3. What's that say? 1,000. Add. 2. Now, I know you can spell 1,000 because you've already done it, haven't you? So when I say 1,000, you write, don't you? Equals. Can you spell equals in maths? What's the number? 5. What's the word? Oh, you're good at these. See, what it means is, when we say 3,000, we're thinking of 3 of those things called 1,000. 2, not of those things called cups anymore, is it? It's of those things called 1,000. It's lots. Equals 5 of those things called 1,000. So, by knowing that and knowing what it means, you can work out that 3,000 add to 1,000 equals 5,000. Next one. Right, you're right. Go. 3. Good. 100. Good. Add. Good. 200. Can you spell 100, okay? Yeah. Equals. What's the number? 5. What's the word? 100. Well done.
She told me about the 1,000 was shouting at me. And I couldn't quite get over why she was just saying 1,000, but now I understand that it's a word and not a number. So yeah, that's sort of helped to explain how she's learning mathematics. So that's really, really handy to have seen that.
She'd come back, she'd come home, she says, Mummy, she says, 2,000 add 3,000 add equals 5,000. I was like, what? So yeah, I was very surprised.
When you say 9, ding, this means those things called 10. It's 9 of those things called 10.
When children go home and they'll describe numbers as 3t or 2t, it does raise a few eyebrows because it goes against convention. And I know Richard's spoken about convention and how that's easily overcome. What we need to explain to parents is saying 3t and 2t is part of a fundamental process, mathematical process, which enables their children to access mathematical knowledge much more easily, much more freely.
Let's take your test then. Read that. 4. Good. 3. Yes. Try this. 3. That's good. 4t. 3t. 2t. 1t. naughty.
It certainly helps with the child at home to understand what his way of thinking, but rather than, like Richard said, what we did at school all those years ago. But so that does make sense in that respect. Takes some getting used to, I think, with the 20 and the, was it 2T1, whatever. Takes some getting used to, but at the same time I can understand the logic behind it, which does make it a lot simpler.
That says 2, doesn't it? How much is there here? 2. How much is there here? 3T. How much is there here? 2. How much is there here? 3T. How much is there here? 3T2. I'm going to start by putting 3T2 on the maths table. Or do I write? Lots of cups. 2T1. You written that? I would write that, don't I? Equals. But now, of course, I can't really count the cups because they're not there. But I do notice there's 2 here and 1 here. 2 add 1 makes 3. That's 3 cups, isn't it? There's a lot more because there's 3T here and 2T here. That makes 5T, doesn't it? So there's definitely 5T cups and there's 3 cups, all on the maths table. If I show you what's on the maths table, there's 5 teacups and there's 3 cups. How much is there here? 5T3. And that's how they learn it, so that they can now go 2 add 1 is 3 on the maths table. 3T add 2T is 5T on the maths table. How much on the maths table? 5T and 3 is 5T3. And we learn to write it like that.
Children will remember it if it's a visual thing that sticks in their mind, rather than just something that they have to look at, perhaps just a whiteboard.
When the children see this, on the board, they're taught to do this. 3T2 add 2T1. Have I written that okay? Have I written that okay? Have I written that okay? What shall I write now? Equals. Watch me. And the equal sign makes a picture of the maths table where they're going to put the cups. So they now go 2 add 1 is 3. How much is there here? 3T add 2T is 5. If we can achieve some measure of consistency with those parents, then we're actually a long way to enabling people who, young people, who in the past have said, I can't do maths, to become really quite mathematical.